So on behalf of, my name is Victor Kadri. I'm currently PhD in Design Informatics. On behalf of the authors, today I want to present our previous work related to additive manufacturing approach for sustainable heritage. So in this case, we take two case studies, Middleton Church in Groningen and Maurice House Museum in Den Haag. Yeah, so basically the idea, the background of this project is coming from the traits between human and environment. So if we take a look from human factors, so there's a conflict and war that can destroy buildings. And yeah, as you see probably here, and as you know probably, in Middle East, some museums and heritage buildings were destroyed by ISIS, and then that just happened, and it not only destroy the real artifacts, but also the cultural values of the buildings itself. And recently we saw the Notre Dame in Paris, and then yeah, it's also a tragedy for us, and also for the cultural heritage in this case. And for the environment, there are two probably. In this case, we categorize into natural disaster and aging. It cannot be denied by any building, so it must be affected by that over time. And so these factors, directly can affect to the vulnerable architectural structures in this case, and then specifically to the heritage building. So how can we deal with that? So so in the preservations, so by definition, basically the preservations is the activity or process of keeping something fairly alive, intact, or free from damage or decay. And then, there are a lot of techniques for the preservations, or we can call it conservations as well. So ranging from the very small, very vulnerable materials like textile, ceramics, coming to the huge and large structure of the building scales. And also, another one is this also another preservations. So this is an isolated village in Wairabo in Indonesia. So one small village that has received the highest awards from the UNESCO Asia Pacific Heritage in 2012 because they can build and renovate, they can restore their traditional houses from 5 to 7. But the thing is, before they do the construction, they need to, so from 5 to 7, so they need to add 2 more. But the thing is, because the knowledge is discontinued and on that generation, so they need to deconstruct one building. So they need to destroy one building in order to understand the complete structure. Every single knots in every column, the specific materials that they would like to use, and all the things. So in order to build the 2 new constructions of the buildings of the houses, and then but finally they did it. But what I like to emphasize from this image is like the type of construction like this. Well, yes, that's really useful. But if we compare to the current technology, we can. Well, it is time consuming because they need to destroy one first, and then they will build again 2 more. But also they need to learn how to understand step by step. So it will not only time consuming, but also the high cost of the constructions process in this case. So by making use of the current technology, So the cutting edge technologies, in this case, 3D scanning and the 3D printing, so we can fill some gaps on that, let's say, conventional conservations in this case, in order to explore more the digital before turning to the real object again. So yeah, the workflow just basically so from the real objects, so we scan the objects and then we get the digital objects and then we do manipulations based on the objectives. So we do some adjustment, optimization and kind of things, and then we 3D printing the object to be a real object again. So that there are some, and then we can do some customization on this part. So based on the potential application of this technology, so yeah, based on the potential application of this technology, we are inspired by this to our projects, and then we sorry, I think this is still the yeah, the previous one, but yeah, that's okay. So we come up with the two scenarios. We adapt the two scenarios in this case by using the experimental techniques and also the real conservations as it is. So meaning that the conservation technique is like to really produce the real object as it is, as the original artifacts in every single way, like including materials, including colors and roughness, anything. But in other part is experimental techniques. So we do some explorations, basically, not only regarding the materials, but also how do we would like to achieve one objective, like how the current technology can correspond to our idea, how they can catch up each other. The current technologies can already support our idea to have this real color 3D printing. Yeah. So this is yeah, we apply those scenarios in one of our projects is Marius Middlesom's Church in Groningen. The idea behind of this project is what happen if there's a natural threat affects the church in Groningen, because I forgot the time of the earthquake happened in Groningen, but it affected some surface, some wall in the church was really brick, and then there are some gaps over there. So that's why we come to the site and then we scan the entire buildings, and then we select some part, and then we optimize the structure, the surface of the data set, and then we come again. Okay, and we come again to the 3D printing of the object. Yeah, so this is, and then this is the second one, is second case study, Mauritshuis Museum in Den Haag. This is the Middlesome Church in Groningen. So this is the spot of the 3D printing. Yeah, so this is the material exploration. So the objective is to not only to have a real color of 3D printing that close as possible with the real objects, but also to have a lightweight structures when we mount the 3D printing objects next to the real one. So we would like to have it like that, and also it deals with the glossiness and the material properties as well. And this is the Mauritshuis Museum in Den Haag. Yeah, it deals with some color properties, and yeah, we do some modeling and prototyping. And because of the limitation of the printer, so we need to divide it by 4, and then we do some testing as well for the Maurits House museums before we come to the real objects. But there are two major differences here. The first one, we try to print. We try to go for the 3D color 3D printing. But the thing is, at that time, it was 2017. At the time, there's still no companies that can provide that things. So the thing is, we go for the foil printing. So we print the object first, and then we apply the foil on it. But taking into account the roughness of the surface, and in order to be perfectly aligned in the objects. But for the Maurits House Museum in Haag, because we did this after this, and then we go for the color 3D printing, and then this is the results basically. Yeah, and then we do some exhibitions. So that's the scales, and this is the real one. And so this is to answer how the current technology can respond our idea to have a really real conservations in this case by using the technology, the current technology. But we believe that in the coming years it will become more feasible, and of course it's also deal with some budget, because this is still very expensive to afford. And then to add the SDGs, so we propose the sustainable workflow in this case. So from the dataset 3D scanning, so we have the original datasets, and then we can do to approach conservation experimentations. So by doing some object typology, so for the conservation, we go for the real artifacts. For the experimentation, we can go for the ornaments and mass product. For the mass customization, and then for the user of conservation, for the museum organizer or heritage conservators, and then it's basically for the segmented user. But for the experimentation, it goes for the researcher, designer, and then more what ideas in the context. For the conservation, it's a museum, national archive, and for the experimentation, it goes to home industry, shops, and then So, and then we come with these 3 strategies for the SDGs: quality education, decent work and economic growth, and sustainable citizen and communities. Thank you.
Great. Thank you.